A warm greetings to all. I am Dr. Murli Manohar, working as an Associate Professor in the Department of Electronics and Communication Engineering, MITS, deemed to be University, Madanapalle. So today I will discuss antenna and radiating systems. Antenna and radiating system. So first question is that what is an antenna? So antenna is basically a transducer which converts an electrical quantities like voltage and current into electromagnetic waves or vice versa. So antennas have many applications such as in mobile communication, so all mobile phones have inbuilt antennas. And the second application is that WLAN, wireless local area network. So our laptop connecting Wi-Fi has also an antenna. And the third application is that television. So old antennas are used for TV reception purpose, but nowadays disc antennas are employed. And the fourth application is that antennas are used for satellite communication. And also it is used for rocket and missile applications. So now question is that what is the cause of radiation? How does charge radiate? Like all EM waves, the source of electromagnetic waves are some arrangement of charges. But neither charge at rest nor steady current generates the EM waves. So it is required to generate the EM waves to have accelerating or deaccelerating the charges. So if you let me consider a giant sphere with radius r and which includes the source of electromagnetic waves at the origin. So total power passing out through this spherical surface that will be given by the Poynting vector. So P total is equal to surface integral over closed contour in the presence of average Poynting vector. So here why we have taken average? Since the medium is infinite, so since r tends to infinity and there is no possibility of reflection, hence so S average is equal to real part of E cross H star and into ds. So basically Poynting vector, which is nothing but the square of the electric field. So here basically this is the energy per unit time and that is radiated into free space. So based on this we have three cases. So first case is that does stationary charge radiates. Stationary charge will not radiate. Why? Stationary charge means no flow of charge. No flow of charge. If no charge, then no current, and if no current, substantially means that no magnetic field. Magnetic field. And if no magnetic field, then no radiation. And since EM wave constitutes both electric and magnetic fields, therefore stationary charge will not radiate. So stationary charge, so here I will write stationary charge will not radiate. Now, next point is that when the charge is moving with constant velocity, does it radiates? So, charge moving with constant velocity will also not radiate. So, for radiation to occur, the Poynting vector must decrease 1 by r square. So, if you consider the surface area of the sphere, which is nothing but 4 pi r square. So, to occur the radiation, this should be 1 by r square. And from the Coulomb's law, the electrostatic fields decrease at 1 by r square. Similarly, from the Biot-Savart law, the magnetic field decreases at 1 by r square. So total decrease in the Poynting vector, whenever we take E cross H, so total decrease in the Poynting vector, that will be 1 by r4. So if you take this, if you multiply this 1 by r square into r square, so 1 by r square term will remain same. So therefore, no radiation will occur from the structure. Now the third case is that when the motion is time varying current or acceleration or deceleration of charges, then it will radiate. So time varying current or acceleration or deceleration of charge will radiate. So basic radiation fundamental equation is that L di by dt is equal to Q dV by dt. So where L is the length of the current element and di by dt is the time changing current and Q is the charge in coulombs, and wherever dV by dt is the acceleration. So it simply states that to have a radiation, there must be a time varying current or acceleration or deceleration of charges. Static charges implies that no radiation. Whenever charges are moving with uniform velocity, radiation will occur if the wire is bent curve. Radiation will not occur if the wire is straight. However, when the motion is time varying current with acceleration and deceleration charges, then only radiation will occur, even if the wire is straight. So let us, to understand the radiation fundamental in a meaningful way, consider a section of the transmission line. So this is a section of the transmission line wherever this conductor will produce the field due to current flowing in this direction. However, this conductor will produce a field due to current flowing in the opposite direction. So when the spacing between these two conductors are very small, then in that case it will not radiate, because whenever spacing between these two conductors is very small, then whatever the field produces, that could have given you the net power flow through this structure, but they are cancel each other. Therefore, we will not get any radiation. Now, if we separate the distance between these two conductors, now the length become comparable to lambda. So same equal and opposite current cancellation will not happen in all the directions. It is possible that when I am going to this direction, that is a perpendicular to the plane of the paper, so I might not get the radiation. But whenever we are going in some other directions, now the phase is coming without of space, and that might compensate the phase difference between two currents, and I might get the radiation. So to have a radiation, two things must be there. So first point is that time varying current, and second point is that spatial imbalance between these two conductors. So if the spacing between these two conductors are very less, then in that case due to equal and opposite current takes place, and hence no radiation. So there should be spatially imbalance between these two structures. Let us very crudely, very qualitatively just take the consider this section, that ends of the open of this section will be 0. So here current at this point. So whenever you consider this as a transmission line, then at this point the current is 0, and at this point current is maximum. So whenever you plot the current distribution, so current is 0 and current is maximum here, again current is 0 and current is maximum. So at every lambda by 2, current is 0. Similarly, we can plot the current distribution here also. So at every lambda by 2, current is 0. However, voltage is maximum at the ends of the transmission line. So now if we starts flaring this structure, and if the flaring is gradual, so if we start flaring this structure, so since the transmission line, which is a function of impedance, and impedance is a function of inductance per unit length and the capacitance per unit length. So whenever we go ahead, the inductance per unit length and the capacitance per unit length goes on changing. So transformed impedance also go on changing. However, if the flaring is small, then we can consider this end the same that should be considered at this end. So at this end, the current is minimum. So therefore, we can plot the current distribution like this. Similarly, at this end, current is minimum, and here maximum. Again, we have a minimum. However, the current is flowing equal and opposite. So similarly, here also we can give the direction of current, this and this. So now, this structure basically see the matched load. And we know the free space has a intrinsic impedance which is nothing but 377 ohm. So this structure tried to match with this impedance. So wave is propagating in this way, and when wave is try to reach at this point, and it will try to match the impedance, which is nothing but 377 ohm, and wave is getting launched. Okay, and the electric field, direction of electric field will be like this, like this. However, if we flare this structure completely, so if we flare this structure completely, so in this case, current maximum will be here, and then in a similar way, maximum will be here, and maximum will be at this point. So now, the beauty of this one is that the current, both currents are flowing in the same direction, and it will provide the fields, and due to fields, antenna will radiate in particular direction. So provided if you provide the voltage, so in this way antenna radiates through the structure. So whenever we take a section of the transmission line. So today in this lecture we will cover up to here. If you have any query, then you can raise. Thank you.